Today we're at scenic Frazier Park, home of El Tejon School, and today we're here to... Once again, we're at El Tejon School. I've got 8th grade student Giggles with me here. Sarah, how are you today?
Good.
All right, you going to be able to do this problem?
I hope so.
All right, here we go. Let's go ahead and turn around. All right, go ahead and put the number 30 up there. Do you know what a factor is? A factor of a number. What's a factor?
The numbers that will multiply to make 30.
Okay, numbers that will go into 30 evenly, right? How many positive factors does 30 have? So how would you figure that out? We want to
4.
know how many factors 30 has.
4.
So,
So there's 1 and 30,
okay,
and then 2 and 15, and then 5 and 6.
anything else go into 30?
No.
All right, so you went from 1 to 2, because you know 1 will go into anything, multiplied by itself. Then you know 2. How did you know 2 went into 30?
It's an even number.
It's an even number, and you know 2 times 15 will be that. How did you jump to 5 then?
Oh, I missed 1.
You missed one. What'd you miss?
3 and 10.
Oh, okay.
And then
So now how many factors does it have?
8.
All right, so the first time you had 6, now you've got 8. Are you sure you're going to stick with 8?
Yeah.
Positive. You don't get to change it again. You set?
Yeah.
All right. So we know the 1 times 30, 2 times 15, the one that you missed, but you realized was 3. 3 times 10, but then you went to 5. What's the matter with 4?
It doesn't go into it evenly.
It doesn't go into it evenly, right? So you know to skip that, and by knowing your multiplication facts, you know that. So then you go to 5, and then you went to 6, right? Because 5 times 6. How do you know to stop then?
Because 7 doesn't go into it. Neither does 8
Okay.
or 9, and then you already have 10.
Okay, but why don't we do all the other ones? So I'm trying to see if you know that. I mean, you realized it, but I want to see if you understand how you knew to stop then.
Well, 'cause nothing else goes into it evenly.
Right, see, the 5 and the 6 are right next to each other, right?
Yeah.
So once you go 5 and then 6, right, and these are each other, you know you're done. That's how you can tell, because sometimes you'll have a large number that you have to do this with, and when you get the numbers right next to each other like that, you know you're all set, as long as you have all these other ones in there, all right? So you first of all had 6, but then you realized that it really 8. Sarah, nicely done. Easy enough problem, wasn't it?
Yep.
Okay. We're at El Tejon School. 8th grade student Stori is with me, and we're about to work on some triangles. You ready?
Yes.
Finally, we can get to this. All right. So there are 3 main types of triangles. We have an equilateral triangle. What can you tell me about that?
It has all equal size, all equal sides.
Okay, why don't you just go ahead, and it doesn't have to be perfect, but draw me an equilateral triangle.
Okay.
Good, so by putting those marks in there, you're identifying that all of the angles are the same, okay? But we could even go pretty far on this. What's the measure of each of those?
It depends on how big the triangle is.
Well, how many
Right.
degrees are going to be in a triangle?
360, right?
That's in a quadrilateral, so in a triangle, we're going to have 180.
Okay.
All right, so,
All right.
but we're not even going to deal with that. So we have an equilateral triangle, all right?
All right.
What is another type of triangle?
Isosceles
Isosceles. And tell me about an isosceles.
has 2 equal sides, but
Right.
one of them isn't.
Right, so let's say you have 2 longer sides and one's very short at the bottom or whatever. So go ahead and draw me out an isosceles. There you go, nicely done. So obviously not all the same.
Yeah.
And what is the other one? There's a third type of triangle, a scalene.
Scalene.
There you go, scalene. And what's the
Scalene.
deal with a scalene?
It has no equal.
So go ahead and try your hand at that one.
No, no,
There
no.
you go. There,
No.
Just shorten that one up. There you go.
I'll do that.
All right,
If that looks like it'll work.
that'll
I'm
work. So we're
thinking.
going to work with the isosceles one.
Okay.
All right. So two of the sides measure 15 centimeters, and the other is 10 centimeters.
15. Do you want me to write that figure?
Well-
Or is that okay?
No, how do you know that the two are 15 and not 2 or 10?
Oh.
Okay, so you're doing the angles.
Wait, didn't you say 2?
Well, here are the two measurements.
Okay.
One side, all right, one side is going to be 15 centimeters. That's the length of one side.
Okay.
The other side is 10 centimeters, all right?
Okay.
So we have two of the three sides. The question is, what is the maximum length perimeter of the triangle? What can the maximum be? So
Okay.
you can make one 15 and one 10. So how would you like to label those? So which one would you like to, if you're looking for the maximum?
The maximum, you would have the 2 bigger. 15.
Okay, so where would you put the 15?
The 15 on the side.
And the
then
10 would go. So then what would the maximum be?
The maximum would be.
The perimeter would be,
40.
right, it
right?
would be 40.
Yeah,
right?
40
So
centimeters.
The maximum would be 40 centimeters, all right? And that's the answer, that's what I was looking for.
Okay.
If you wanted to do it differently, if I said what was the lowest it could be, how would you label it then?
I'll just do that.
And then what would it be?
Be 35 centimeters.
There you go. All right,
right.
nicely done. Not that bad, was it?
Nope.
All right, no need to get nervous.
I'm sorry. The lead flat radius, please